Hello. So yeah, this is another stream thingy. Oh, there's that strawberry guy again. We're gonna be kind of continuing off yesterday. Yesterday was about Numpy. It's a library in Python, but today we're going to be doing it on Pandas, which is also another library in Python, but they're used for different things. Today we're also going to be importing Numpy because we still need to use some arrays inside of Pandas. So yeah, let's start. So first off, we need to import Numpy and Pandas. I'm probably going to scroll in a bit. Okay. So we need to import Numpy as NP and then import Pandas as PD. This is so that we can actually use a library since it's not already built into Python. And if you don't already have installed Pandas or Numpy, then you can go into CMD or command prompt and then just pip install and then Numpy like so, or Pandas like that. So if you don't have it, then you go ahead and do that. But if you're not sure whether you have it or not, we can just test it out in the code. Okay, so let's go back in. Okay, so now let's look at this one, creating a series. So like in Numpy, there is an array, but in Pandas there is a series, and a series is created from an array, or it's kind of created like an array. Sorry, I rephrased it wrong. And so in here we have a list called labels, A, B, C, and then this is another list called my list that has 10, 20, and 30. And there's an array that is np.array, which is how to create an array in Numpy, my list. So it turns my list into an array. And then it has a dictionary that contains A, which has a value of 10, B that has a value of 20, and C that has a value of 30. So these are the things we're going to need to create a series. So in here, down here, we have pd.series data equals to my list. So this one will just grab all the data from my list, and then it puts into a series. So let's run this. I keep on forgetting to run, like so. We need to wait until it connects with my Google account. So we're almost there. Okay, it's connected, and let's run this one first. Oops, error, my list is not defined. Let me see. Oh, I have an underscore in there for some reason. Okay, there we go. It should work. And then let's move on to pd.series data equals to my list. So here we go. Okay, as you can see that this data, it's stored. This series, it has the data from my list. You can see that slot 0 is 10, slot 1 is 20, and slot 2 is 30. And then you can also see the D type of it, which is integer, like so. And this one, pd.series my list, comma label, let's see what this one does. This one basically grabs the labels, right? And instead of that 0, 1, 2, 0, 1, 2, it grabs ABC instead of this, and it just replaces 0, 1, 2 with ABC. Okay, let's move on to the next one. Numpy array to Panda series. So we're going to convert an array to a Panda series. Okay, let's do it. So now we're going to just convert it with this simple thing, pd.series, and then the name of the array, like so. Now it's a Panda array. From this, it's into a Panda array now. 1 second. Okay. So now let's move on to this one. pd.series array, comma labels. So this one would add ABC just like up here, instead of 0, 1, 2. And now let's convert a dictionary to a Panda series. So pd.series dictionary, and it will turn out like so. And in here we're going to do pd.series data equals to labels. So we're going to get over here it's going to be ABC now, like so, ABC 0, 1, 2. And now let's move on to this one. This one is pd.series sum print and len. Not only can series hold lists, arrays, dictionaries, integers, it can also hold other stuff like objects or built-in functions. So these are some commands we can use in Python. Some print, print for like hello world, and len, which is length, to find out how long something is. We can also store this inside of a Pandas series, like so, and you can see that it is built-in function sum, built-in function print, and built-in function len. And then the D type is object. So all these are objects. And then let's move on to the next one. So series 1, okay, SER1 is series 1, equals to pd.series 1, 2, 3, 4. So that's the first column, which is a list. And then there's an index of Thailand, USA, Japan, and Italy. So Thailand is 1, has a value of 1. USA has the value of 2, and Japan has the value of 3, and finally Italy has the value of 4. So if we were to series 1 USA or America, then it would come out 2, since that is its value. Oops, sorry, I forgot to run this code. Okay. It would come out 2 since that is its value, and you can see here. And let's move on to series 2. So this one, instead of Thailand, we have Antarctica, and we still have the same amount, right? But we changed from Thailand to Antarctica, and now we're going to try to add these two series together. All of the rest of the countries are the same. We just swapped out Thailand for Antarctica. Let's see what happened. So if I forgot to run this again. Okay. So as you can see, Antarctica, the value is not a number, and Thailand, it is not a number. However, the rest does just add up together. So like Italy is a value of 4, and it adds up to 8. Japan has a value of 3, adds up to 6, and USA has the value of 2, and it adds up to 4. By the way, these numbers, I didn't actually purposely put them. I just put 1, 2, 3, 4, and then just thought of countries and I put them there. Okay, it doesn't mean anything. And then Antarctica and Thailand, on the other hand, they couldn't add up because Thailand had no index that matches Thailand, so it couldn't add up together. Instead, it found Antarctica, and of course, Thailand and Antarctica are not the same. So, and it also applies for Antarctica. It can't find Antarctica in the index, so it just, the program went out not a number. Alright, let's move on to data frame. Okay, so in data frame, basically it creates kind of like a graph or like a more visual of this. It's a better visual. So let's do it. So from numpy.random import randn. This is to import randn, and np.random.seed 101, and it will just create in here we will just make it create a 5x4 well, I don't know how to call it, an array, yeah, sorry, a 5x4 array. And then we're going to move on to this one, which is df equals to pd. It's a long one, but basically, let me run it for you. It looks really complicated, but it's not. I can better visualize it from here. So it basically makes it so that it's the y, right? Yeah, the y consists of a, b, c, d, and e, and then the x coordinate consists of w, x, y, z. So yeah, it just creates it creates the x and the y coordinates, and then it also has all of this inside here, like so. And yeah, that's it. It's pretty simple. It's just creating a data frame. And we also use the dot split command to have all these individually, and they're going to be split by the spaces. Okay, let's move on to selection and indexing. So dfw, this one will basically just get us the column w, like so. So if we look here, it matches together of 3, 1, 8, 4, 3, 1, 8, 4, and 1 at the bottom. So it just gets the column w if with this command. And what if we did w comma x? What would it do? It would just grab the chunk of it, so it would grab w and x together. And let's try it with w and z. Like those are far apart. Would it come together? Would it connect together? Let's find out. So z. There we go. It just comes together. So it basically kind of deletes these two and just smashes in together. So one could say like so. and it just grabs it from this graph. So yeah. And type df.w, we can just look at what type it is, just like we would for like variables or like dictionaries or like list. We could do with this too, and it is a pandas.core series. That's interesting. And now let's look at removing columns. So let's make a data frame really quick so we can like visualize it better. Okay, so this is our data frame without actually editing anything. And the way to remove how do you call it? Remove a column is df.drop, and instead in here we have w axis equals to 1, and it'll drop w. And remember, it's important to have axis equals to 1 because without this it won't work. And axis equals to 1 is specifically for columns. You can see here that it is gone, w is gone. And now let's drop a row, shall we? And in a row the axis is 0 because it's not a column. And we're going to drop row A. And there we go. Now would you look at that, w is back, but A is gone, but w, the column w, is back. This is because the df.drop command is just temporarily dropping the column or the row. It's not actually permanently doing it. So if we want like a permanent drop where it just like it's gone forever, then we can use this one. Let me just create a new data frame so we can visualize it better. Okay, this is our data frame. As you can see, everything is back in place. None of it was actually like temporarily permanently deleted. It only deletes when this code is run. So you can add more things on this code, and then you can like temporarily delete it. However, the original is still there. But we're going to do a command where it permanently makes it gone forever. So the command is kind of similar to the top one, except after axis there is in place, and in place equals to true, meaning it's going to be gone. So we're going to drop the column w, and we're going to make it gone forever, like so, and then we will make the new data frame. As you can see, w is gone for good. It's actually not here anymore, and we can just do this with all the rest too. The same code applies, just that if you want to drop a row, then you change axis to 0, but if you want to drop a column, then you make it 1. And then remember to set your name correctly. I think it's case sensitive too, so yeah, be a little aware of that. Wait, what? What's the chat? Okay, I mean, okay. Okay, well, we're not gonna look at that too soon. Well, there's something in the chat. So, I mean, there's lots of chat, but then this is one of my relatives. Yeah, so, not sure if that's fake or something, but, okay, that's cool. Anyways, let's move on. So, now let's move on to, where were we? I lost track. Oh yeah, we're gonna create a new data frame since our last one was messed up. So we're gonna create a new one. This one is just simply copy and paste the code from above. This one, and then you can restore your data frame. However, the data inside of the data frame is changed since it's random. So yeah, like so. And now we can just create the data frame, and it is different because it's how do I call it? It's different because it's random, so it's not actually the same thing that's up here. You can see like so. And now let's just do more stuff with data frame. So we're going to be selecting a row. This is so that we can like minimize it. So we're going to be looking at A, specifically this row. Don't be confused by the letters that come out, because I got confused by that too, but basically it's saying W is this, X is this, Y is this, and Z is this. Don't get confused because it might be on the Y coordinate plane. However, it's actually the X coordinate plane. It's just flipped around. So as you can see, it selected A, 99, 19, 1.13, and 0, 0, 0. And you can see it just got this row. And let's move on to selecting columns. So we're going to be selecting the column W. You can see that the code is a bit different. This one is df.locate or LOC A, and df.w is to select the column. df.a I'm pretty sure also works. Let me see. No, I don't think df.a works. So if you want a row, then you do this, but if you want a column, then you do like so. Okay, perfect. Okay, let's move on. So now we can just once we know how to do that, we can just grab a row and column. Remember that row comes before column. So we will grab like this chunk df.locate b and y, so to until y, I guess, so until here, this 2x3 area. Okay. Alright, so in here we have it 0.03 and 0.03. Okay, and the number might be longer since it has more room, so it could expand more, but yeah, that we got it. Alright, now we can make the data frame again, like so. There we go. This is actually not necessary. We can actually just not have to do this one, but I'll just create a new data frame so that everything is fresh, and let's run our data frame to just visualize it. Okay, and now we can also do a lot more stuff for the data frame, like check if each of them, like if one of them, no, sorry, just to check the values if they are more than 0. If they are, then we say true. If they're not, then we say false. So as you can see, here comes the data frame. So true, true, false, true, 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 false, true, and so on. This is, you can actually change this to like a higher number. However, our data, if we remembered from yesterday, is limited. So yeah, if we change it to 8, I'm pretty sure all of it's gonna go false, since I don't think anything goes higher than 8. Yeah, I don't know the exact limit because of this. I looked over here and I found a -2, so I don't know the exact limit. However, I do know that it's not over 10. Yeah, not over 10 and not over -10, or under, sorry, not under -10, so it's around there. So I'm just gonna leave that at 0. Okay, let's move on. Now we can also create a new ID, or like a new index for our data frame. So if you were to run that, and let's run this. This one is to just replace the index and replace A, B, C, D, E, I'm pretty sure. Okay, and then we'll just do df.reset index, and there we go. We didn't actually replace it, we just added a new column called index and then replaced the numbers or like the letters in there. You can add it like this too, and let's move on to the next one. df states equals to new ID. I'm pretty sure this one will just, let's see. Okay, so it does just I think, wait, what does it do? Okay, so it replaced this one with this, and then it moved index, renamed it to state, and then put it in our the right hand corner. So it just renamed index to states and then put the letters into the right hand corner, and it replaced 0, 1, 2, 3, 4 with CA and Y and all of that. Okay, let's move on. And let's do this one. Oh, now it just moves it to the top, to the front, so that we can show that this one's the state. And it deletes this one and makes it more nice. However, I'm not sure why these ones are floating, but they are. Okay, let's move on to multi-indexes. So let's just run this one, shall we? We'll see what it does. It's another, okay, so in here it just creates a multi-index, and inside of here we have G1, 1, G1, 2, G1, 3, and then it repeats again at G2. And yeah, and we have the higher index too, as for this. And this is actually a tuple in here. This is a tuple inside of this multi-index. These are tuples. So we're almost done. So let's move on to df equals pd.dataframe. This is quite long, but I'll show you what it does. So it basically makes it so that the two columns are called A and B, and the rows are called G1 and G2, and inside G1 we have 1, 2, 3, and inside G2 we also have 1, 2, 3. And yeah, they just store the values in there. The random values, by the way, this is like creating a data frame like what we did up there. Okay, let's move on to the last one. These two are really simple. It just grabs the row. So this one, it gets G1, all of G1, and this one gets all of G2, just like it taught before. And yeah, that wraps up today's lesson. How long was the stream? Around 20 minutes. That is pretty good. It's not as long as yesterday's, which was 30 minutes, but yeah. So I'm going to also leave this link for this collab file in the description, just like you did last time, and you guys can just copy it into your Google Drive and just experiment with it from there. You can't actually edit my original slides since I'm going to give you viewer permission, and you can just copy it, download it, and whatever you want to do with it, and then you can experiment on it by yourself. And yeah, that ends my stream today. I hope you found something useful out of this. Goodbye.